Good evening, students. Today we are doing the second part of force for IGCSE level, and today we are going to cover momentum, number 2 impulse, number 3 conservation of momentum, and number 4 vector addition. So let us start with momentum. What is momentum? Momentum actually represented by small letter p, and the formula of momentum is mass into velocity. And as far as unit is concerned, unit of mass is kg, and velocity of unit of velocity is meter per second. So momentum unit will be kg meter per second. So let us see this momentum concept with an example. Let us say there is a car which is in A position, and while it is in A position, it had velocity 10 meter per second, and the mass of the car is 100 kg. After some time, it reaches to B position while its velocity is 20 meter per second. That means increased from 10 to 20, and mass is 1000 kg. The mass will remain same only. So while it was in A, the initial momentum, that is P suffix I, initial momentum equals to mass into velocity. Mass was 1000, so 1000, and velocity is 10, so mass into velocity, kg meter per second. While it was in B, momentum is PF, that is momentum final, and it is again mass into velocity. Mass was 1000 and velocity here we have 20, so it is 20 into 1000. So what is the change in momentum? Change in momentum means final momentum minus initial momentum. So finally we had 20,000 final momentum, and initial momentum we had 10,000. So if we subtract these two values, we will get 10,000 kg meter per second momentum. So this is our change in momentum. Next, impulse. From the definition of force, we know force equals to mass into acceleration. Now we can write acceleration is as v minus u by t. Now if we multiply this mass with both the values of velocity, we get mv minus mu divided by t. And if I take this t cross multiply with f, so it will become f into t equals to mu minus mv. This is actually known as impulse. So ft is impulse, mv minus mu is also impulse. So what is the unit of impulse? So f into t is impulse, so Newton into second. So impulse is Newton into second. Also change in momentum, that is m into v minus m into u. So kg meter per second is also unit of impulse. But actually impulse we use when the force applied on an object is for a very little period of time. For example, we can say when in a cricket match, when a bat hits a ball, there is a force applied on the ball by the bat, but this force is being applied on the ball for a very fraction of a second. The time period is very short. So here we can say we can calculate impulse. But when the force is applied on an object for a long period of time, we do not calculate impulse. For example, when we push a car for 20 minutes or 30 minutes, so in that case we do not calculate impulse because this time period is very long. Let us do one example for impulse. Example, in a cricket match, a batsman hits a ball by his bat with 200 Newton force. The bat and the ball remain in contact for 0.5 seconds. calculate impulse. So here force is given 200 Newton and the time period of contact is also given 0.5 second, and they are asking impulse. So impulse formula, force into time, we know. So impulse equals to force into time. So force is given 200 Newton, time is given 0.5 second. So it will be 100 Newton second. So this is the value of impulse. Our next topic is conservation of momentum. So we already understood what momentum is. Momentum actually mass into velocity. So let us first understand what is conservation of momentum. We will understand it with the help of an example. Say two cricket balls are there. Both are having same masses, but one is at a still position, like its velocity is 0 written over here, and the other ball is moving at a velocity 2 meter per second towards the second ball. Now after some time they will collide with each other. Here collision is happening, and after collision they will again separate with each other, but both of them are having velocities. Now this ball is moving with 1 meter per second velocity. This ball also moving with 1 meter per second velocity. So what happens here? Before collision, the momentum of this ball was 0 because its velocity was 0, but it had momentum. Before collision it had momentum, but after collision its momentum decreases because its velocity decreases, whereas its momentum increases because its velocity is now 1 meter per second. Now now during collision, if one object gains momentum, then the other loses an equal amount of momentum. That means before collision, whatever momentum the system had, after collision they will be having same momentum. There will be no change in momentum. This is called conservation of momentum. So let us say two balls are there of different masses, and their initial velocities are also different, u1 and u2. Collision happened, and after collision the bigger ball gains v1 velocity and the smaller one gains v2 velocity. So according to the conservation of momentum, we can say the before collision the total momentum of the system is m into u1 plus m into u2, total momentum of the system, and after collision total momentum of the system will be m into v1 plus m into v2. So this is total momentum of the system after collision. So from the conservation of momentum law, we can say before collision total momentum, that means this thing, before collision total momentum of the system equals to after collision total momentum of the system. So let us understand this concept with the help of few numericals. A 35 kg boy jumps from rest into a moving trolley of mass 70 kg and already moving at a velocity 5 meter per second to the right. The question is, what is the velocity of the trolley after the boy has jumped in? So two conditions are there. Before the boy jumped into the trolley was moving with 5 meter per second. After jumping onto the trolley, the boy is now on the trolley and we have to calculate what is the velocity of the trolley now. So we don't know the velocity v now. So let us say before collision. So this situation before collision between boy and trolley. So before collision, total momentum of the system, that means mass into velocity of the boy plus mass into velocity of the trolley. Mass into velocity of the boy is 0 because the boy was at rest. It is said over here. Jumps from rest. So 35 into 0 plus mass into velocity of the trolley, 70 into 5. Number 1. After collision, what will be the situation? After collision, the situation is like this. Here both the masses are combined. So mass of the boy plus mass of the trolley is combined now and both are moving with velocity v. So total momentum of the system is the mass of the boy plus mass of the trolley into v, as they are having common velocity. So both of them will be moving with the same velocity. Number 2. Now according to conservation of momentum, we know before collision total momentum of the system equals to after collision total momentum of the system. So 1 equals to 2. So we have written it 1 equals to 2, and from there we have calculated value v, which is 3.33 meter per second. Let us do another